Thanks for joining this session about clean code. And before I really talk about clean code, I'm going to do just a quick introduction. So I'm Olivier, CEO and the co-founder of Sonar Source. So I started this a long time ago, basically 15 years ago. And Sonar Source is a company based in Switzerland, in Geneva. And Sonar Source develops and promotes 3 products: Sonar Lint, Sonar Cube, and Sonar Cloud. And we have a booth downstairs if you want to talk more about the product. Otherwise, this is probably the last time you are going to hear about Sonar in this talk. Before I go and I start, can I ask who knows Sonar? Who uses Sonar? Very good, very good. Who doesn't know Sonar? Okay, that's okay. Always risky as a question to start with. Anyway, so what I'm going to do today is I'm mostly going to talk about code. I feel, as a software engineer, that we always forget how important code is. We always tend to spend a lot of time, a lot of energy, a lot of focus talking about many other things, and we, I would say, neglect code when actually I would argue that this is one of the most important things when you build and operate software. And I would say that, in my view, there are 3 really important things when you build software. One is a team. This is super important. Unless you have a team, it's going to be hard. I do not think that Copilot will run, operate, maintain, adapt, etc. software. It will be helpful. AI can certainly help. Many other things can help. Frameworks can help. But at the end of the day, software is going to be built by a team. The second thing is, and there is no priority order here, but these are the 3 most important things in my opinion. The second thing is code. The code is super important, and I will come in a minute to it. And the last one, of course, is the software itself, which is, what does it do? Is it doing what it's supposed to do? Does it behave the way it's supposed to behave, etc., etc.? It's extremely important, of course. Moving a little bit in, how do we at Sonar see the world? So in case you didn't recognize, this is a tree. It's a very modern tree, actually. And we feel that software is a little bit like a tree, which is there are 2 parts. One is the part which is above the ground, the part that you see, what you really aim for when you do software, which is, this is basically the functional part. What your software is going to do, how it's going to behave, what service it's going to render to the business. And that part at Sonar, this is really the part we don't take care of. We take care of all the rest, which is the part which is below the ground, the root, basically, to make sure that the root of the software are solid. And this part is extremely important. It's called, it's quite funny, it's called non-functional requirements, all the things around stability, security, sometimes performance. Also, sometimes performance can also be a functional requirement for certain domains. And these parts are very often the parts that we forget to specify when we do a software specification. You know, like if you ask people and you say, do you want the software to be stable, fast, secure, etc., the answer is going to be, of course. But this is not written anywhere. And this is what, so the top part, we call it, this is how the software behaves. On the bottom part is how the software performs. And we really focus on the second part, but if you think about it, when you talk about code, code is going to dictate both. Code is going to dictate how the software behaves, and it's going to dictate how the software performs. Code, I would argue, is the only real asset that you have as a software engineering team to build your software. Everything else is either a commodity, which you can replace, or a disposable, something that you can throw away when you don't need it anymore. Code is the one thing you cannot replace, which is not a commodity. It's going to really dictate these two things. Right. I forgot to say, I will make sure there is time for questions. At the end, I will try to have 10 minutes. So very, very important. And it is super important to do clean code. And the thing which is, this is kind of difficult to talk about clean code because people ask, what is clean code? And very often, what you see in your software is when the code is not clean. So we tend to talk about bad code, junk code, sometimes dirty code, but not too much. So I'm going to talk a little bit about not so clean code on what happens when your code is not clean. So what happens is you get what we call technical debt, which is you get small problems here and there. And if you have a little bit of technical debt, if you have a few issues in the code, it's okay. It's actually not bad to have a few problems. What's really bad is when you have so many problems that you only deal with these problems and you cannot basically improve the software anymore. You cannot add more value to the business. You keep spending all your time trying just to basically survive. This is security problems, stability problems. You want to change something and you break something else, etc., etc. Who has never seen that happening around them? Okay, good. I'm glad to see that I've got a room of fans here. So we call that technical debt, a little bit of technical debt, okay, a lot of technical debt. You basically spend your entire life working on this, and honestly, this is not fun. This is not much value to the business. There is also an argument that the only way to really measure technical debt is this way. I actually do not think this is true. I think we have evolved. There are now tools and products to do this, and I will talk a little bit later about this. Now, so back to the question, what is clean code? We believe that clean code, and I'm going to spend a little bit of time on this to explain. Clean code is code which is consistent, intentional, responsible, and adaptable. Why is it important to formalize this? It's important because I want to map this to actually the consequences of not having clean code a bit later on. So why is it important that code is consistent? Because many people are going to interact with that code, and you do not want each and every one to define their own styles or ways of doing things. You want the code to be as consistent as possible in order for the team to really own it and for anyone to be able to change something. That's one. The second thing is, if you think about it, who had issues about debates about left curly braces or right curly braces? Okay, only two. I mean, you guys are too shy. I'm sure many more. Honestly, should a curly brace be on the right or on the left? To me, doesn't matter. I've got a preference. I've got a personal preference, but what really matters is that we agree one way or the other, and then the whole code is consistent. Why? Because if we don't do that, every time you are going to hit one, every time you are going to read some lines of code, you are going to wonder, okay, is it on the left, is it on the right? These 2 seconds you are spending there is just a waste of time, a waste of energy. If you multiply it by whatever, 10 people in your team, whatever, 100 team in your organization, at the end of the day, it's a massive waste of time. What value do you get for this? You just won the ego battle around, okay, we won. I mean, I win every time I put a curly brace on, but everybody wins, but at the end of the day, the team loses. So consistency is super important, and here I'm talking about style, but I'm also talking about constructions, which is to solve a certain problem, we should try to always use the same approach, and that needs to be agreed with the team. So that's one. The second thing is intentionality. This is all about logical errors, code that can never be reached, so dead code. Would you really intentionally leave code that is dead in your program? Apart from confusing other people, you don't want to do this. But it's also about memory leaks. If there is a leak in your code, it means your code is incomplete. If there is a security vulnerability in your code, which means if somebody can inject data which is going to reach a critical component of your application, something is missing. In that case, a sanitizer is missing in your code. So these are all the kind of problems that we classify about intentional. Adaptable is about you need to be able to change your application. You need to be able to make changes to your application in a way which is reasonable, fairly cost-effective, and without breaking everything. So anything which has to do with complexity of code, anything which has to do with duplication, anything which has to do with design will fall under that part, and this is obviously extremely important. When people refer to technical debt, very often it's because they cannot change the software anymore at all, and generally this is because they have a major problem in that category. And the last one is about the code has to be responsible, which is it has to be inclusive. You cannot just steal code somewhere and use it in your application, etc., etc. So the last part will not really have an impact on your software or on your team, but it's more like it's more about compliance. So why does this matter? This matters because specifically the first three categories here will have two impacts. One, it will have an impact on your dev team. I already mentioned if the code is not consistent, every line you are going to wonder, is this, more that? Try to read an email which is written in many fonts or many size of font, or which is larger than the screen. When you start to have to scroll horizontally, that becomes very painful. So we'll have an impact on your team. It will also have an impact on the software. If the software is not, if you don't use sanitizer to sanitize data, which is injected by users, at the end of the day, somebody will catch it. It's just a matter of time. Somebody from security will catch it, and they will come back, and they will ask to fix it, which is fair enough, which means rework, you have to reload the whole program in memory, and all of that to add no value to the business. The only thing you do is you avoid to destroy value for the business. That's the only thing you do when you fix such an issue. So my three pillars, team, software, code, Here we are. Okay. So now what I would like to do is I would like to do pretty quickly a mapping here between the categories that I mentioned and what happens to the team and to the software. So the responsible part, mentioned it already, this is mostly about compliance. This is for the people in the team to comply to mostly to company rules, and for the software to comply to industry standards, like you shall not steal code. That's kind of, I would say, that's a legal requirement, but also to certain industry standards. If you guys, I don't know if some of you work in automotive industry. In automotive industry, you have certain standards that needs to be followed, and here your code being responsible means you are going to follow these standards. So first, the rest is a kind of a pyramid, which is everything is built on top of previous level. So if the code is not consistent, we always have say not in our world. This is going to be super difficult for your team to be accountable for that code, basically, which is very difficult to have collective ownership. It's going to be mostly each and everyone owns a little part of the software, and it's difficult to get all of that together. If the code is not consistent, it's going to be very difficult to maintain the software, which is every change you want to make is going to take a bit longer. It's going to be a bit more risky. And maybe before I go up here, I should just summarize how we see software. It's a very simple way. Software is being run. So basically, you run it in production, and you need to be able to maintain it. Maintaining just means make sure it runs smoothly. If there is a bug, you fix it. If there is a security vulnerability, you fix it. If there is, I don't know, like a button needs to be changed slightly, you can change it. But this is the kind of changes you are talking about when you talk about maintenance, which is things which will not impact the behavior of the software, i.e. the functionality of the software. Evolving means you are actually changing the functionality of the software. You are changing the behavior. It's something totally different. I mean, in both cases, you are changing the code, but it's the kind of code change is totally different. So if the code is not consistent, it's going to be hard. It's going to be harder to maintain. So this is really the first thing you need to obtain. The second thing is intentional. The code has to be intentional. If it is intentional, it means it's going to be much easier for the team to be predictable. Any surprise in your code, like I'm going to just pick random examples here, but things like always true, always false conditions are leading to confusion and potentially to bugs. Why would you have an always false condition in a loop? Because you felt it was super smart to actually keep that piece of code, but that nothing can reach it. Sure, there are other ways to do this. So anything here which, if your code is very intentional, your team is going to be more predictable. Why? Because when you make a change, you will not have to spend minutes, days, or minutes, hours, days to understand what the code does. That's for one. Plus all the problems that you are not sending to production, you are not going to have to fix them to have the software running smoothly. And obviously, to run the software, it's going to have a direct impact on this running the software. The last part is adaptability, which is, it's really about, as I mentioned earlier, design, architecture, but also things like copy-paste in the code, which eventually lead back to a design problem. Unless your code is adaptable, at some stage, it will be hard to make it evolve, which is this software which you see that are parallelized at some stage. Most of the time, this is because code is not adaptable. And if the code is adaptable, your team will really become effective, because when you say this is going to take me a day, it will really take you a day to change. There is a very interesting diagram which represents actually the real work that is done by teams. I don't have it in this presentation, but I'm going to describe it, which is, if you think as a developer that you are spending 30 hours to do development. So let's say you do 10 hours of other things, not development, not direct development. The reality is probably that you are spending half of this really in doing effective development. You are probably spending, out of the non-effective development, you are probably spending a third in extra time because the code was not really consistent, intentional. This is what we call the low level, the code level, technical debt, which is basically all these little things that make you waste a little bit of time. And you are spending another 70% of that time is spent actually to fix this existing problem that you have in the code, which is basically reworking. This, I don't know if it explains directly why every time we say it's going to take a week, it actually takes 2. But probably that's one of the reasons. Okay. Okay. So what? I'm not going to go into how to measure what you can do, etc., etc. There are quite a few tools out there to do this. And most of these tools enable you to find problems. So Sonar finds problems, but you also have tools like, on each language, things like CPP check, find bugs, check style, etc., etc. There are a lot of tools out there that can help you find problems on problems of different natures. A lot of tools look at security problems today. Security is important. Don't get me wrong, but I think only looking at security is a big mistake, which is you are solving one side of the equation, which is the security side, but there are many other aspects which, in my opinion, impact much more engineering team. So all these tools they can measure on them. You are presented with results, and then what do you do? That's always a big question. I summarize it with I don't know if you guys know a product called Snyk. So Snyk finds security vulnerabilities, and Snyk actually stands for "So Now You Know," which is exactly what the tool does, which is to show you the thing. Each and every company then, each and every team within a company then has their own policy or rule or process to solve problems. In most cases, the policy is the policy is we leave it each to every individual to do whatever they want on the problem. That's roughly the policy, unless this is something which crashes the production or this is something which creates a real vulnerability. We leave it up to engineers to decide what they are going to do with the problem. In some cases, people block. They stop you pushing more. And very often, it gets escalated. And after a while, this becomes impossible to continue to block. So people have to just let go. By the way, if you ask, I think if you ask most engineering managers or CIOs, CTOs, or head of engineering, if you ask them, do you think the quality of the code today is better than what it will be in 1 year or worse than what it will be in 1 year? The general answer you get is it is better, which means people expect that the quality of the code is going to decrease throughout time. And I think overall we have come to a point where we feel this is, we are, how do we say, it's a little bit like a fatalism, which is there is nothing we can do about it. I had a very good conversation earlier about this, which is, hey, we don't really have time for this, or we try to block some time to fix it, etc., etc. It doesn't work. These approaches do not work. Okay, so how can we impact? So most important thing is when you think about this problem, you should think about it as a water leak. That's a big, big leak, but I would I would argue that the leak is probably the same in your organization when it comes to clean code. So, super easy question. When you have a water leak at home, what do you do first? Shut off the water, fix the leak, right? Why do you not start to mop the floor before shutting the water? No trap, huh? Tell me. What's that?
More water will come.
Exactly. It's useless, right? You are mopping, more water is coming. So totally useless. Think about code. Let's say that after this session you liked it so much you decide to install Sonar immediately. You run it, you have 10,000 issues. What do you do?
Stop adding more issues.
You start to mop the floor?
Remove Sonar.
Exactly. I mean, I don't know why when it's about water, this is very intuitive. There is no point to mop the floor until we have fixed the leak. Super intuitive. We would all react the same. When it's about code, for some reasons, the first thing we want to do is we are like, oh, I've got this issue and that issue, etc. I have to fix them. I have to fix them immediately. And if you think about it, there is a big water leak in the meantime, which is people keep developing the same way they have always developed. And you are basically fighting against you're climbing a mountain. You will never have an impact by having this approach. And to me, this is, when it comes to our domain, this is this thing which is stopping us to solve the clean code problem, which is super obvious problem since 10 years ago. I said 50 years, so now it must be since 60 years. We know about this. We know the impact. We know we shouldn't do that. And we don't really do something about it. And I think this is simply because we look at the wrong problem. We are looking at making the software totally clean before we fix basically the leak. So in order to solve that problem, we think that there is a much better approach, which is super simple and super effective, which is to do what we call clean as you code. It used to be called fix a leak, but apparently clean as you code is better for engineering organizations, where basically what you are saying is every developer owns their code, and as such, to do a good job, you should not introduce new problems. So every time you change code, every time you add code, you don't introduce problems. We are asking nobody to solve problems that were introduced 10, 15 years ago, not the goal. That belongs to someone else. And maybe we should do something about this, but this is not developers' responsibility to actually fix that while they are developing. So the only thing we are saying is, as a developer, you should be developing new features or changing existing features, and as part of this, the code that you deliver should be clean. If you think about it, this is kind of just very basic and standard, right? What else would you expect from any good developer? You also get a chance to learn as you code. And one big upside of this approach is it's a forward-looking approach. What do I mean by this? I mean, it doesn't matter what your standard is today. You can always increase it later on, and you have built no backlog. I'm going to take a very simple example about this, which is if you think about code coverage. So if you start to do unit tests in your organization and you want to have, if you want to monitor coverage, which, by the way, you should do, what you would do is, rather than looking at the overall coverage, you would look at the new code coverage, which is every time you change a line, every time you add a line of code, it should be covered. You may have a pretty junior team, which is not really used to write unit tests. In that case, you want to start with maybe like, okay, 50% of the, I should have 50% of coverage on the new lines. It's okay. If you want to raise it to 80% later on, it's okay because the new bar will be on the future code, not on the past. So you are totally fine to progressively increase this, which also makes it much easier to onboard people on the approach. Okay. As we say in French, the second key school effect, which probably doesn't resonate here. So there is another upside to this, which is, so first big thing is developers will do a good job, which is all the code that they deliver will be clean. The second impact that it has is that because by nature we keep changing software, I mean, software is a never-ending, it's a moving, how do we say? It's a moving asset. You always change software. You need new features. You need to comply to regulation. There is a new version of Java, et cetera, et cetera. So because we keep changing software, every time we change a code, its quality will increase. At least not decrease, but in general, it will increase because you will change lines of code. So industry standard is that in average, 20% of a code base gets changed every year. So it means if you follow this, after 1 year, 20% of the lines of code will be clean. Think about it. After 5 years, that might be 50% because there is overlap, so it's not going to be 100%, of course. If you thought about cleaning up 50% of your software, that would be probably an impossible job. Here, you do it as you develop code. And of course, all of this has to be super integrated to the development pipeline, which is you cannot do clean as you code by looking at what's going to go to production. It's too late. When it's about to go to production, I mean, you won't be able to stand and push back on this. So it really has to start in the IDE. It has to happen at the change request, merge request, pull request, you name it, level, which is this is where, between the IDE and the pull request, this is where most of the issues are going to be caught. Anything that passes pull request should be like an exception. It should be a one-off, but there shouldn't be many things to catch after that. Oops. Crap. It doesn't want to come out. Okay. Here we go. So, couple of takeaways about this presentation. So one is bad code will impact code, of course, but also it will have a big impact on the team. Code is this is a work environment of developers. If the code is bad, it's a bad work environment for developers. And it will impact the software. Bad code is not fun because after a while, you're going to spend most of your time to actually deal with the consequences of the bad code and with the bad code itself. Knowing is not good enough. Sorry, I said I wouldn't speak about Sonar anymore in this presentation. I will speak about Sonar again. I hear people saying, it's okay, we do our static analysis with Sonar. Okay, it's not okay actually. What do you do with it is the real question, which is knowing, sure, better than not knowing, but hey, guess what? If you don't know about the quality of your code, I can tell you, it's crap, okay? No, if you don't have a product, whatever, Sonar or another, you bet the code is bad. Code is too complex that we can really have it clean without some external help. And the last point is the clean as you code will help to close this gap. I know it sounds simplistic. We started to use it at Sonar Source. We actually built that approach for ourselves because we were struggling at every release. We wanted to have at the time, 70% of code coverage. And every single time we released, guess what? We had 65, 67, 68, which was good, which was okay, not too bad. But we couldn't get naturally at 70. To make the 70, we were adding unit test classes that unit tests that actually cover big classes, etc. We were playing with the numbers to feel good in our mind. And at some stage, we were like, okay, 3 founders of this company, software engineer, we totally believe in the value of this. If we cannot achieve our goals, who can? I mean, our goals on code quality, who can? We need to come up with something that will work and will be simple to use. We started to use it, so it's very difficult mentally to stop looking at the overall coverage. Very difficult, because you are at like 65 and suddenly you say, we will not look at the overall coverage of the product anymore. We will only look at the coverage on the new code. And then we decided our minimum should be 80%. And after a while, we made it 85 because the team said 80 or 85 is actually the same. And since then, we have seen the whole graph of overall code coverage. You know, this thing we don't look at anymore, but we still have a graph. We saw it increasing slowly. And it was very steady, no specific effort, but at the same time, a big reward. So sounds very simplistic, but it's really impactful. It is simple. And this is it. And I'm happy to take questions, and I think there will be a microphone for questions. And if there are no questions, I can keep asking you questions.
One, two, hi. Thank you for the presentation. It's pretty useful. I think I'm going to take this back to my team as well. I've got 2 questions. One is a little bit of an observation. You used the word intentional in one of the slides to explain how to understand code and some traits that the code is supposed to have. I was wondering whether the word intuitive, because would make more sense, because intentional, you know, sometimes people want to write code that is not intuitive and they are doing it intentionally. I had a colleague who wanted to write, convert some logic using binary code,
yeah,
because it would be faster, you know.
Yes.
It wouldn't be intuitive, but it was intentional. I'm just wondering about that, to better understand the word intentional. And the other question I have is about cleaning as you code. One of the problems that I personally have is that when I try to develop a feature and finish the code, I will clean as I go. But then, quite rightfully, a reviewer is going to say, I noticed that you changed that thing where you were coding, focusing on bringing in this new feature. Maybe you should raise a different PR to clean up code and raise it and do it as a separate thing. And I try to adhere to that because it makes a lot of sense. But sometimes I catch myself thinking, I'm never going to find the time to do it later, so I want to push it in this PR. And I get sloppy. Do you have any advice on how to avoid that?
So about your first question, I think we have a so intentional, I would say, is the main category. Under this, there are subcategories which I didn't go through. One of them is complete. One of them is intuitive. It's not called intuitive, but it relates to what you say, which is one of the things when you read code is it has to be, if you ask 10 developers to read it, the 10 developers should have the same understanding of it. So definitely. Probably this is obvious, yes. You took a photo, right? Okay. I thought you knew it better than I do. On the second thing, I think, so when we say clean as you code, what we mean is your duty is that every line that you change becomes yours. So you have the responsibility for that line. If if you change a method, you become the owner of that method for the time you change it, and you should not introduce new problems, basically, in that method. When it comes to remediating existing problems, so if they are part of what you are changing, not a problem. If they are not, this is when there is a debate. I think if you are in the code, you see something obvious and you fix it, this is totally fine. But you also know that sometimes you're going to fix something which seems to be very simple, and it might have side effects. So always, you have to always be careful. The big upside of doing this as you develop new features is that they will be, people are going to be willing to do the testing, to make sure it's all fine, et cetera, because you are bringing value to the business. So the engineering team, the users, everybody is going to be willing to do the effort to push the new feature out. When you start to randomly change bits and pieces, this is difficult to explain, that you decided to invest time in something that doesn't have direct value to the business, and you broke the application. That's a bit more difficult. So to your point, I wouldn't do, if you fix something randomly, I wouldn't do a separate PR. It's okay, but I would not try to do this. To me, I mentioned it earlier, I see many companies where they do like, I've even seen startups where they do like the technical debt day. This is Wednesday, and on Wednesday we fix the technical debt that we introduce on the other 4 days of the week. It's like, why don't you clean as you code? I mean, if you don't introduce the problems, you don't have to fix them. And the best moment to actually, the best moment to work on that is once it's fresh in your mind.
The clean as you code concept is great. I've been doing that with test coverage for a while. But when it comes to other issues, I imagine Sonar Cube has all sorts of lint and logical analysis. It's tough to change the culture of a team. How do I get the culture of where I work to accept this? And how do I get the leadership to invest in tooling to enable us to do so?
So now I'm no, I was thinking, okay, for the last part, I will put you in touch with a salesperson from that organization. No, but I do not think this is right, what you said. Sorry. That's why I was carefully thinking about the way I'm going to answer, which is, I think if you ask your organization, which means the developers, the testers, the managers, the business, if you ask everybody to invest into something, like the technical day week or the technical day month or something like this, it's going to require a lot of convincing. It's going to be really hard, and you will really need to convince people. Now, if you're telling people, hey, from now on, whenever you make a change, that change cannot introduce new issues. It may be like, it may seem like a big cultural change, but at the end of the day, how can anyone push back on this? I mean, honestly, how can you push back and say, no, I really insist, I would like to introduce this big bug or this security vulnerability. I want to leave something to, to the next generation of developers. So, and I would also argue that doing good code does not cost more than doing bad code. Arguably, sometimes you have to live with the existing, and you cannot just refactor all the time when, but in most cases, it will cost you no more. The big problem, to me, the biggest problem is when you learn about the problem, it's too late. I asked earlier who uses Sonar. Lots of hands raised. Okay, now who uses Sonar Lint? Oh, no, not bad, not bad. But who doesn't use Sonar Lint? Here you go. Probably a lot of people we see at the booth, they know Sonar Cube, sometimes Cloud, rarely Lint, which is, if you have it in Lint, you are going to see that as you code. So basically, we used to say Sonar Lint on the tagline was fix issue before they exist, which meant, okay, they will exist only if they reach Git. Here, if you fix them on your local machine, nobody will know. And this is really, really the best place. So to your point, I understand it's a change. But to me, this change is pretty much unchallengeable, which is you need to get management buy-in to make sure it's going to be enforced. But to me, this is it.
Thank you.
Maybe next year you can tell me how it went. Are there other questions?
Hello. Thank you for your talk. It was really nice. Before I start, I just want to say I love Sonar. Okay, don't hit me. But
I'm getting worried now.
in fact, when newcomers come to did the microphone die? No. When newcomers come to our team, I tell them Sonar is your best friend, not your enemy. But do you think that sometimes zooming into the code too much will backfire you? Like if you zoom into the code and start to get a little obsessed with the cleanliness, this will affect the architecture in a way that is irreversible. So like sometimes you can have the cleanest code ever. It's the most readable, fun to work with ever. But it has that one architecture bug in it that you cannot detect
Yes.
with static code in it. So
Yes.
do you think that having a lot of zoom in, why am I saying this? Because when you say you need 80% coverage,
Yeah.
you will do whatever is in your power to add coverage. As you said, like you will add coverage to those big classes. In our case, we do a little more than that. But it will affect the architecture.
No. If you look at the new code, sorry, for code coverage, if you look at the new code, you are going to have to cover the lines that you change or added. So you cannot cheat with the way we were cheating at Sonar Source anymore. But I think I understand your question. So, okay. So the people who should be obsessed with code are the people who work at Sonar Source, okay? This is, we should be obsessed to really try to provide the best-in-class tool to help other companies. I fully agree with you, which is being obsessed about code will make you feel like you are doing a super good job when maybe you are completely missing the mark. Exactly. Totally agree with that. But don't forget, this is a talk where I'm trying to get people to understand that actually doing a better job is very simple. So I have to be obsessed with code in that talk to actually get people to come with me. What we are talking about here at the end of the day, once you have all moved into clean as you code approach, we are just talking about basic hygiene, which is the code that you deliver has the right level and you don't have to put more effort. You can actually spend your time and energy into solving bigger problems like architecture, functional, innovation, et cetera, et cetera. Totally agree. That should be built in the code that you deliver. But because it's not, we need to do this special effort here to actually get people to on board with the idea. So, agree.
So is the goal to get 100% clean code? Because it's not, is it?
Okay. If we fix the rules that are not super good in the product, some rules are like arguable, and we should fix that. Then I believe on new code, 100% should be the goal. Is it the goal for the overall application? No. But the more you make changes to this application, the closer you are going to get to 100% clean code.
And these rules are more like team agreed standards, or are they general rules from, let's say, generally on the code language itself, or?
So there is a little bit of everything, which is some rules are standard across languages. Some rules are directly on construction of the language. Some rules are even on version of the language, which is to do certain things in a newer version of the language, you have a better construction. So we recommend that better construction. And some rules are like basic style. To me, I mean, the way we are thinking about it today is the curly brace. Just to go back, there are two rules, and you can activate one. You could activate the two if you wanted to. One says left, one says right, so you could get a violation every time there is a curly brace if you want to. And to me, it should be one rule, and it should be mandatory. You cannot deactivate. Like, you have to choose. If you cannot choose which side your curly brace is going to be, you don't need to use Sonar. I mean, you are going to do nothing with it. This is the base of the base. And now you all feel I'm a clean code psychopath. Okay, fine. Does that answer your question? Okay.
Yeah, hi. I have a friend, and he has quite controversial approach, and he said that basically they're trying to reuse the code as much as possible, copy-pasting and so on, because it reduces the complexity, and it makes it much easier for new people who are coming into the system, because when you're starting over-engineering your code, introducing a method which calls a method, which calls a class, and so on, it becomes really complex and hard for some. So is there a golden, like, point
yes.
here?
I think over-engineering is as bad as under-engineering, which is, think about a copy-paste. I mean, if you have been in a system where there are lots of copy-paste, you need to fix something, and you're going to fix it in several places, and it doesn't work, and then you find another place, on another place, on another place. This is extreme. It's a big waste of time, basically. So, yes, over-engineering makes it very difficult to understand the system as a whole, and you start to make random changes. But if you under-engineer, and if you just copy-paste everything, I mean, if it's a marketing, if it's a website, which is going to be up for 3 weeks, it's okay. Disposable application, but I cannot think about another case where it's okay to actually replicate the code everywhere, because when you need to make a single change, you are going to have to do it everywhere also. So to me, this is really a balance. And by the way, there is a big stop sign now. So thank you very much. I will finish to answer your question after that. Thank you very much.
Thank you.